Welcome to the final part of Chapter 4. We're going to look at just a few more examples of continuous compounding. In 2000, the population of a nation was 3.5 million people, and in 2025, it is projected to increase to 7 million, so we see that in 25 years it doubles. Find values for the function below to model this, and we have the function f of x equals principal times a to the x minus 2000. Well, in this function, x is going to be the year, and f of x is going to be the population in that year. So we don't know p and we don't know a. So those are the two values we need to figure out. Well, we actually do know p. It's 3.5 million was the original population. And since we have a coordinate of 7 million in 2025, we can actually solve for a. So let's do that. It would be 7 million equals 3.5 million times a to the 2025 minus 2000. Do you see that? So now we can use that information to solve for a. So to start out with, divide both sides by 3.5. Okay, and that 3.5's cancel. 7 divided by 3.5 is 2. And that makes sense because we're doubling, right? So it's good that we have a 2 there. 2025 minus 2000 is going to be 25. So 2 equals a to the 25th power. So to solve that equation for a, I simply need to take the 25th root of both sides. And so a will be equal to, let's see, I need to take the 25th root of 2. So I think it's 2, then you click that, and then you get 25. And I believe that's correct, 1.0281. In fact, let's take that to the 25th power just to be sure. And I should get 2. And I pretty much get 2. So make sure you can take the 25th root on your calculator as well. So here's our updated function then. F of x, the number of the population, will be equal to our initial population, 3.5 million, times 1.0281 to the x minus 2000. So the function input is the year, x, and when we crunch that out, it gives us a population value for f of x. Next question says, estimate the population in the year 2010 to the 100th of a million. So to do 2010, we just plug in 2010 there and solve. So f of 2010 equals 3.5 times 1.0281. And we plug in a 2010 there, and I'm going to go ahead and do 2010 minus 2000, which will just be 10. So we just get a 10 right there. So now it's just a matter of plugging it into the calculator. So 1.0281, raise that to the 10th power. And once again, I got that from doing 2010 minus 2000. And now we just multiply that times 3.5. And we get our answer. So we get that the population there will be approximately 4 point, and they said 100th of a million. So 4.62 million people. And to make sure your answer makes sense, check back and make sure that it's below 7 million. This is like my third take of this video because I accidentally put 7 here instead of 3.5, and I got an answer that was higher than 7 million. And that wouldn't make sense for in 2010 you to get an answer of higher than 7 million. So that's how I knew I had made a mistake and had to redo the video. So keep an eye out for that to make sure your answers are making sense. Use F to determine the year during which the country's population might reach 10 million. So again, by 2025, we were at 7 million, so we should get an answer of higher than 2025. So what we're going to do now is plug in 10 million into f of x. So 10 million equals 3.5 times 1.0281 to the x minus 2000. This time we're solving for x, which represents the year. So now we can do that. So let's start by dividing by 3.5. Okay, that cancels, and we get 10 divided by 3.5, which is 2.857. As usual, if you need to be more accurate, use more decimals. That's equal to 1.0281 to the x minus 2,000. Next thing I'll do is take the natural log of both sides. So let's take the natural log of that and get 1.0498. That was the natural log of 2.857 is 1.0498. And now we take the natural log of this. And so we get e is equal to the natural log of 1.0281 to the x minus 2,000. Okay. So the reason we do that is because now we can bring down that power. So now we can write 1.0498 equals parenthesis x minus 2,000 times 1.0281. Okie dokie. So, almost done. We're solving for x, so let's divide by 1.0281. So here we go. We take this number and divide it. Oh, I forgot to take the natural log of it. That's why. So I just realized I made another mistake. I shouldn't be dividing by, this is why you need to be really careful when you're doing these. I just realized I made another mistake, and I'm going to leave this in the video so you can see my mistake. You see how easy it is? This should be the natural log of this number. So let's do that and take the natural log of it, which will be 0.0277. So as you can see, that makes a very big difference. So this is x minus 2,000 times 0.0277. So I knew I was getting something weird because I was getting an answer of like 1. And we needed the answer to be bigger than at least 25. So be careful there. I'm leaving this in so you can see that even I can make mistakes. Don't skip steps. This is x minus 2,000 of the natural log of this number, which now gives us this. So now we can divide by 0.0277. So 1.0498 divided by 0.0277 is equal to, there we go, 37.89, I'll just round it to 90. So is equal to x minus 2,000. And then you add 2,000 to both sides, and we see that in the year, in approximately 38 years after 2000, in approximately the year 2038 is when the population will be 10 million. So as you can see, be very careful when you're doing these problems, and you'll get the right answer. So this answer seems to make sense because we're higher than 2025. All right, so let's do the next one. This is the last one. In an epidemic, the number of people who are not immune and have not been infected decreases exponentially. So you start with a healthy population, then as the infection spreads, it's continually compounding as more and more people get sick. Here's the function. Find the number of susceptible people at the beginning of the epidemic, after 10 years, and after 6 weeks. Excuse me, well, at the beginning of the epidemic, the number of healthy people is just going to be 18,000. Okay, so that's easy because that's just our initial value. The number of susceptible people at the beginning is just your initial value. In fact, if you notice, if you put in a 0 here, this becomes 0, so you get e to the 0 equals 1, and so you just get 18,000. So that's really nice because the math checks out. Now to do 10 days and 6 weeks, we just plug those in for t. T is in days, so let's do f of 10 for 10 days. And this is just going to be a crunching of the calculator. So that's all you got to do. Negative 0.04 times 10 is equal to negative 0.4 is what that's equal to. So let's just do E. Well, I'm going to type into my calculator 0.04, make it negative, and then do E to that value. And so we get 18,000 E to the, oh, I already did E, times 0.96. So 18,000 times 0.96. So just take that number, multiply it by 18,000, we are now down to 17,294 healthy people if you round. So in just 10 days, we've gone to 18,000 healthy people down to 17,294. To do 6 weeks, the process is exactly the same, except remember this is in days. So do 6 times 7. 6 weeks is 42 days. And so just calculate f of 42. So just plug in 42 for t because it's in days. Make sure you don't overlook that. That would be easy to miss on a test if you're going too quickly. So let's do 0.04 times 42 equals, let's slap on the negative sign, take e to that value, and so this answer will be 18,000 times 0.186. And I'll put in a 4 just to round it to the 3's place, round it up to 4. Or actually, I don't even need to do that. Since that's in the calculator, I can just multiply by 18,000. So there's approximately 3,354 healthy people after 6 weeks. So you see why there's a lot of urgency when there's an epidemic to help people. In 10 days, we were at 17,294, but then 6 weeks later, after the initial infection, we're only down to 3,354 healthy people left. That concludes Chapter 4. I hope you enjoyed learning about logarithm and exponential equations. The log rules are probably the most important part of this chapter and knowing how to use those log rules. So make sure you memorize them, and I wish you the best of luck on your exam. If you have any questions, please leave them in the comments. And if this was helpful, please make sure you like and subscribe. I will see you in Chapter 5. Take care now.